in this section we're talking about position, velocity, and acceleration. It's really easy to do. We will take the minimum difficulty level of this objective, so we're just doing the basics, but in your physics class, of course, you'll get much more detail. So we have a position function. For me, that's always going to be given to you. Your velocity is your first derivative. Your acceleration is your second derivative. So you have your first problem. If an object is dropped from a height of 100 feet, its position is given by this function. Find the velocity after 1 second. Okay, so your velocity is just the derivative. So if you take the derivative of this function, you get negative 32t. Okay, that's your velocity for all t. In this particular problem, it asks you when t is 1 second. So that means you're going to plug in 1. So your velocity would be negative 32t. Remember, t is 1. So your velocity would be negative 32. Now, as a math teacher, I would accept negative 32, and I'm not tricky on your quizzes about units. But if you are taking this course with a MyMathLab software, they're going to ask you the units. So what you need to know about velocity is you're given feet and seconds. So velocity is measured in feet per second. So your answer would be negative 32 feet per second. Looking at one more of these, the equation of motion of a particle is given by this s function, this position function. S is measured in centimeters and t in seconds. What is the velocity after 2 seconds? The velocity is the first derivative. So your first derivative would be 6t squared minus 10t plus 3. Okay, I tell you in this problem that t is 2. So since t is 2, we're going to plug 2 into that function. So my velocity would equal 6t squared minus 10t plus 3. And I'm going to plug in my time, which is 2. Okay, if I work that out, I get 6 times 2 squared, which is 4, minus 20 plus 3. So 24 minus 20 would be 4. 4 plus 3 would be 7. Okay, now velocity, in this particular case, my units were centimeters and seconds. So velocity would be centimeters per second. The second question says, what is the acceleration? Go back up to the red statement here. This is your velocity. So what the acceleration is it's the derivative of the velocity, or it's the second derivative of the position function. So once you take your first derivative, that gives you the velocity. Once you take your second derivative, that gives you the acceleration. So looking back at this orange star here, my second derivative would be 12t minus 10. Take the second derivative. Now again, just like last time, I said what's the acceleration after 2 seconds? So we're going to plug in 2. T equals 2. That's given to you in the problem. And so your acceleration would equal 12t minus 10. Okay, remember here that 2 is t. T is 2. So you're going to get 24 minus 10, which would give me 14. Now acceleration is measured in different units. So acceleration is measured in square units per second. So when you get down to the units, you're going to have square units. So that's going to be centimeters squared per second. Now that's just the units that are squared, but acceleration is measured in square units per second, and that's what we would get.